During the Apollo program, 12 people walked on the moon. We drilled into it, we even brought back hundreds of kilograms of lunar soil to labs here on Earth, and somehow we still managed to miss something fundamental. How did it take us almost 50 years to figure out it has water? It sounds like something we should have known on day one. We had the actual rocks in our hands. And the thing is, we kind of did know. We just didn't believe it. In March of 1971, during Apollo 14, an instrument called SIDE, or the Suprathermal Ion Detector Experiment, picked up something strange, a signal near the lunar surface. Charged particles drifting where they shouldn't be. Scientists had an explanation, a pretty boring one, probably exhaust, leftover gas from the lander's engines, lingering near the surface. And here's why that explanation made sense at the time. Everyone already believed the moon was bone dry. Every sample said so, every observation said so. So when something weird showed up, the simplest answer wasn't water. It was our own spacecraft is messing with the data. Case closed for the next 23 years. Except this wasn't even a new idea. Centuries earlier, Leonardo da Vinci looked at the moon and wondered if its glow came from water, maybe an ocean reflecting light at us. And in 1961, before Apollo astronauts ever set foot on the moon, scientists at Caltech did the math on something specific. Permanently shadow craters near the poles where sunlight never reaches could be cold enough to trap ice for billions of years. So the idea wasn't new, it just didn't fit the evidence, or at least not yet. Then in 1994, a small US military probe called Clementine took a shot at it. It beamed radio waves into those permanently shadow craters at the South Pole, the same ones Caltech had described over 30 years earlier, and waited for the echo. What came back didn't just look like rock, it looked like ice. But, and this matters, it wasn't proof. Other scientists using other telescopes looked at similar regions and got different results. The community was split. Still, this was the first real physical hint that something might actually be down there. Four years later, NASA sent something built specifically to settle this. Lunar Prospector. It carried a neutron spectrometer, an instrument that can detect hydrogen hiding underground without ever touching it. And at both poles, it found exactly that. Elevated hydrogen, more than anywhere else on the moon. And with hydrogen being a key ingredient of water, this was by far the strongest signal yet. But since it wasn't an actual proof, the mission team decided to go one step further. The logic was simple. If there really is ice buried in the craters, a high-speed impact should vaporize some of it on contact. That vapor would rise above the surface into sunlight, and for a brief window, telescopes on Earth would be able to detect it directly. So at the end of the mission, Lunar Prospector was deliberately aimed at Shoemaker Crater near the South Pole. A controlled one-way trip into the lunar surface at full speed, designed to kick up whatever was hiding underneath. Every major telescope that could see the moon was watching. The probe hit, the debris went up, and the telescope saw nothing, not even a trace of water vapor. The case seemed closed, and while everyone was staring at the poles looking for ice in the dark, the answer had been sitting in special vaults in Houston for decades. Billions of years ago, the moon wasn't the quiet cratered rock we know today. It was volcanically active, and those ancient eruptions left behind something unexpected. Tiny beads of glass scattered just beneath the surface, frozen in time. In 2008, scientists pulled out the original Apollo samples again. this time with instruments precise enough to detect quantities 1,000,000 times smaller than before. And inside tiny bits of volcanic glass from Apollo 15 and 17, they found water. It had been there the entire time. Later that same year, India's Chandrayaan-1 probe arrived at the moon, carrying an instrument called M3, the Moon Mineralogy Mapper. It didn't dig, it didn't crash into anything, it just measured how the surface absorbed infrared light, basically a chemical fingerprint read from orbit. And in the same dark craters Clementine had pointed to back in 1994, M3 found the signature of water too. Two completely different instruments, 14 years apart, finally agreeing. By 2009, NASA decided to try again. Lunar Prospector had proven the concept, crash something into the surface and see what comes up. The problem was the only instruments watching were telescopes on Earth, too far away to catch anything conclusive. This time they would put the instruments inside the debris cloud itself. Two spacecraft launched together, the Lunar Reconnaissance Orbiter and the mission called LCROSS, the Lunar Crater Observation and Sensing Satellite. The plan was almost reckless in how simple it was. LCROSS would send its spent rocket stage, a 2-ton chunk of metal traveling at full speed, straight into KBS crater, a permanently shadowed pit near the South Pole. Then LCROSS itself would fly through the cloud of debris the impact threw up, just 4 minutes behind, collecting data the whole way down before crashing into the same crater itself, and LRO would watch everything from orbit. On October 9, 2009, they hit. A plume of debris rose several kilometers above the surface. Inside, water vapor. After decades of uncertainty, the moon finally gave an answer. By 2018, scientists had connected the dots. Chandrayaan-1, LRO, LCROSS, and the picture seemed complete. Water exists on the moon, but only in the coldest, darkest places. Permanently shadow craters near the poles where temperatures never rise above freezing. Everywhere else, still dry. That was the common belief. And then in 2020, it broke again. NASA pointed a telescope, SOFIA, an observatory built into a converted Boeing 747, at a crater called Clavius. Clavius isn't in shadow, it sits in full daylight. Direct sunlight hits the ground every single lunar day. And SOFIA found water there too. Not just hydrogen, not just a chemical signature that could be something else, actual H2O molecules. The amount roughly the equivalent of a standard can of soda spread through every cubic meter of soil. It's not much, you couldn't drink it, you'd have to process buckets of soil just to fill a glass. But it's there, in sunlight between grains of moon soil, where nothing was supposed to be. And that changes everything, because the next question is no longer whether there's water on the moon, it's what we can do with it.